Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 7, Infinite Decimals. Classwork opening exercise. Write the expanded form of the decimal 0.3765 or 3,765 ten-thousandths using powers of 10. So what they mean by this is you take the decimal 0.3765 and that equals, and you look at each position. 3 is in the tenths position, so that's 3/10, plus 7 is in the hundredths position, which is 3/100, plus 6 is in the thousandths position. So, time out. I wrote another 3. 7 is in the hundredths position. 6 is in the thousandths position. And finally, the 5 is in the 10,000th position. Okay, it said using powers of 10. So now I'm going to convert that to, let me move this up a little bit. Just so I have some room. Okay, so that is going to equal 3 to the 10, 3 over 10 to the 1, or just 3 over 10, plus 7, well 100 is 10 squared, plus 6 over 10, or 1000 is 10 to the third power, plus 5 over 10 to the fourth. So the answer is 3 over 10 plus 7 over 10 squared plus 6 over 10 cubed plus 5 over 10 to the fourth. Okay. Part B says write the expanded form of the decimal 0.33333 forever and ever and ever. So that is going to equal, so it's 0 point, and how many 3's do they have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. But these dots here mean it continues forever and ever. So in order to write this, it is going to be, we're doing the same thing as we did up here. 3 over 10 is 3/10 plus 3 over 100, which is 10 squared, plus, let me underline these so they're color coded. This 3 would be 3 over 100, which is 10, or 1000, which is 10 cubed, plus this one is 3 over 1,000, or 10,000, 10th, 100th, 1000th, 10,000th, which is 10 to the fourth, plus this one is 3 over 100,000th, or 10 to the fifth, plus the next one is, you choose a color I haven't used yet, 3 over 10 to the sixth, and this just keeps going on and on and on. So it says, have you ever wondered about the value of 0.9 repeating? Some people say that this infinite decimal has a value of 1. Some disagree. What do you think? Okay, so we're going to revisit that. in a moment. Okay, so example 1 says the number 0.253 is represented on the number line below. So the first position is 2/10. So we graph between 0 and 1, 10 spaces, and it's 2 places over 2 of the 10, 2/10. The next one is 0.25. So now we're talking about 2 decimal places here. So that'd be 25 over 10 squared, or 100. So we're going to choose 10 positions between 2/10 and 3/10, 0.25, and 1, 2, 3, 4, 5, and put a dot. And these areas here, this is zoomed in from, so this tiny little section here is this zoomed out. Now we're going to go between 0.25 and 0.26, and that little tiny area here zooms into here. So what we're doing is getting more and more accurate, getting closer and closer to our actual value. So it's a very small section within each of these. So this is 253. Let me change the color. So this is 253 over 10 cubed, or 1,000. So what we're doing is dividing the segment into 10 equal parts. So the first thing we did was took tenths between 0 and 1, divided that into 10 equal parts. Then we took that tenth and divided it into 10 equal parts, making it 1/100th. So this little section here would be 1/100th on this number line. Then we take that 1/100th and divide it into 10 equal parts, and that would be a tiny, tiny little space on the 1,000. There'd be 1,000 spaces between 0 and 1, and this is one of the points on that area. Okay, so example 2 says the number 56, which is equal to 0.83 repeating, is partially represented on the number line below. So we started out with 8/10. From 0 to 1, we broke it into tenths, and we went to the 8th position. Then we take this tenth between 0.8 and 0.9 and make 10 more positions, so that would be hundredths. This is thousandths, 10,000ths, 100,000ths. Okay, but on this one, 0.83 repeating, now pay attention to what's going on here. We are way over here. Here's 0, here's 1. We broke it into 10 pieces for 8/10, and we are 8 positions over from 0, way over here. Then the next number is a 3. So then we broke that into 10 a distance of 10 100ths, and we are 3 to the right of our position. Now if we zoom in here, we only went over 3. Zoom in here, we only went over 3. Zoom in here, we only went over 3. We're going to keep doing that over and over and over. Okay, so now with this process in thought, now let's think about that question back there, 0.999 repeating. And it goes on forever. Does that equal 1? That is our question. So what we are really doing is we're going out, and we're doing this repeatedly, but it would be it'd be looking like this. Here's 0, here's 1. 0.9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 0.9 is right here. Then we would zoom out, and we would be at 0.9 here. And this would be 1 over here. And then we would have 1, 2, 3, 4, 5, 6, 7, 8, 9 in between, and we would end up right here. And it keeps zooming out like that. So this would come down, and this would be 0.99 all the way out to 1. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'd be here again. But then when we zoom it out, so we are going to 1 here, we're going to 1 here. It just keeps repeating. Now it's 0.999 all the way out to 1. and 1, 2, 3, 4, 5, 6, 7, 8, 9, and we put the dot there. So we are going between 0.9 then 0.99. So the question is, 0.9 all the way out to infinity, does that equal 1? Well, the answer is no. We are always going to be just a little to the left of 1. Exercises 1 through 5. Number 1A says write the expanded form of the decimal using powers of 10, and then show on the number line the placement of the decimals. So now do what we just did in those two examples. Pause the video, see how you do, and then come back. Okay, here we go. 0.125 equals 1/10 plus 2 to something plus 5. So all I'm doing is writing the three numbers out. 10, 10 squared, 10 cubed. To plot this on the number line, 0.1 is right here. And let me make straight lines here. So let me just do this. So we're going from there to there and from there to there. Okay. Now we're going to put 2. So now we are at this value here is 0.1, and this value here is 0.2. We're breaking it into tenths. And our decimal place 2 is going to go right here. And then we are going to draw a segment from here to here, and a segment from here over to here. This value is going to be 0.12, and we're going to 0.13. And the value that we want is 0.125, which is 1, 2, 3, 4, 5 right here. So this is 0.125. This is 0.12, and this is 0.1. Okay, number 2, write the expansion of 0.3875 using powers of 10. So I'm going to write 3 plus 8 plus 7 plus 5 over 10 to the first, 10 squared, 10 cubed, and 10 to the fourth. So now we're going to plot 0.3. So 0.123 is right here. 0.3. We're then going to draw a segment. Let's make it thinner. And we're going to draw it from what just happened. Okay. I won't change the thickness then. So what we're doing now is we're taking this and we're zooming in between 0.3 and 0.4. And we are at the 0.8, which is 1, 2, 3, 4, 5, 6, 7, 8 right here. So this is 0.38. Then we're going to zoom in again. So I will go to my line, and we're going to bring this over here and be between these areas. This is going to be 0.38, and this is going to be 0.39. And we're at 7. 1, 2, 3, 4, 5, 6, 7. So this is 0.387. Zooming in, another tenth. This is going to be 0.387, and this is going to be 0.388. And we are at 0.387, 1, 2, 3, 4, 5. 0.3875. 5. Okay, I need to fix my lines though. So when I go from point 3, this is a zoom in from point 3 to point 4, like so. And this should go to here. Okay, they're not going, I'm showing what my zoomed in area is, and I should have done the same up here. So this should be here, and this should be here. That's a zoom in of 1/10 of the area. Okay, so let's try that one more time. So now we're at the expanded form of 0.7 repeating. Well, 0 point, how many is there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. They're only going out 5. 1, 2, 3, 4, 5. And it continues forever. And that equals 7 plus 7 plus 7 plus 7 plus 7 over 10. Over 10 squared, or 100th, 1,000th, 10,000th. And 100,000th is 10 to the 5th. And that goes on forever, so we write plus dot dot dot. Okay, so now I'm going to plot this. Show the first few stages of the placement. So 0.7 is the first 7. 1, 2, 3, 4, 5, 6, 7. 0.7 is between 0 and 1. Can't see yellow, I hit that by mistake. And now we are going to zoom in on that 10th region from here to here, from here to there. This segment here is this 10th inside here. And we're going to go out 7 again, which is here. And to save time, this is a repeat. So what I'm going to do is just keep copying down. Okay, just to save time on the video, since all the numbers were the same, this is just zooming in. This is 0, this is 1, this is 0.7, this is 0.8, this is 0.77, this is 0.78, this is 0.777, this is 0.778, and this is 0.7777, and this is 0.7778. And this point here is 0.7. It's this number here, 0.77, 0.777, and 0.7777. Okay. Number 4. Write the expansion form of the decimal 0.45 using powers of 10. So 0.45 with a bar over both the 4 and the 5 means they both repeat. So that's going to be 4/10 plus 5/100. That's squared. Plus, back to 4, 10 cubed, plus 4, 10 to the 4th. That should be a 5. Plus 4, plus 5, plus 4, plus 5. Over 10 to the 5th, over 10 to the 6th, 10 to the 7, 10 to the 8, and it goes on forever like that. So I first want to plot 0.45 or 0.4, so I go like so. So the first thing I'm plotting is 4/10. 1, 2, 3, 4/10 is right here. That's 0.4. And then I draw my lines from here to here, and from 1/10 over down to here. And now this is going to be 0.4, and this is 0.5. And I want to go over 5. 1, 2, 3, 4, 5 is here. And then we do this. So now this is 0.45. 0.5. This is 0.45. This is 0.4546. We're going in tenths. Hundredths this time, 0.46. So this point was 0. That looks like a 9. 0.45, 0.45 to 0.46. We're at 0.454. So 1, 2, 3, 4. We want our point here. That is 0.454. We're going to zoom in this tenth over to here. So that's going from 0.4. Why does that keep snapping? 454 to 0.455. The decimal is going to be 0.4545. 1, 2, 3, 4, 5 is right here. And then we're going to zoom in on that tenth again and end up at 0.45. This is 4545. 0.4 to 0.4546. We're just adding 1 to that last position and going out 1/10,000th. And so now we are at 1, 2, 3, 4, 5. So I'm going to go out to 4 this time. And it is right here. And that is 0.45454. Okay, now it says to order the following numbers from least to greatest. So we have 2.121212 and it stops. 2.1, 2.2, and 2.12 repeating. Okay. Well, obviously 2.2 is going to be the biggest because this is 2.1 something, 2.1, and 2.1. So it says to order them. So I'm going to put 2.2 last. That is the largest. And the smallest, I would say, is 2.1. And then we need to determine now which is bigger. 2.12, so this is 10th, 100th, 1000th, 10,000th, 100,000th, 1 millionth. But this goes on forever and ever and ever, so this is just a smidgen bigger. So this would be 2.121212. That's this. And then 2.12 repeating is a little bit bigger than this because it's going to go out 1, 2, 1, 2 further. And then 2.2 is the largest. Okay, part B says to explain how you knew which order to put the numbers in. So if we look at what we've been doing in this lesson, okay, it says each number is the sum of the whole number 2 and a decimal. When you write each number in this manner, you get the following expansion. So the 2.121212, which is this one, is 2 plus 1/10 plus 1/100th plus 1,000th plus 10,000th plus 100,000th plus a millionth, 2 1/millionths. Okay, 2.1 is just simply 2 plus 1/10. So 2.1 is here, but if we add this, then this is bigger than that. 2.2 is 2 plus 2 over 10, which is bigger than that. And it's bigger than all these because these added up are never going to be this big. And then 2.12 repeating is this going on forever and ever, which is bigger than that. But even though we go forever and ever, we're adding smaller and smaller portions, it will never be as big as that. So in this form, it is clear that 2.1 is the least of the four numbers, followed by this one, followed by the repeated, and then finally the 2.2. Okay, that is the end of Lesson 7. Review the lesson summary and go do your problem set.